All right, so I want to talk some more about antiderivatives today. Specifically, we're going to start calling them integrals, okay? And I'll explain the difference, okay? So, derivatives can be general. So if I ask you to find the derivative of an equation, d dx of x squared plus 3x plus 5, we get an equation, 2x plus 3, right? So using the general power rule. So that's what we'll call a general derivative, or the derivative of an equation. Now, what does that mean? That equation can be used to find the instantaneous rate of change. Okay, it can be used for that. But this is the derivative. This is the derivative. Okay? Now, we can take that derivative, plug in x equals 1, right? So f prime of 1, and we get 6. That is the equation, that is the slope of the tangent line of that equation. Okay, at x equals 1, that is the instantaneous rate of change at x equals 1. So, general, specific. Similarly, antiderivatives, or what we're going to refer to as integrals, can be general or specific. So a general integral would be this guy here, okay, would be this guy here. And using the power rule, we would take and break these into 3 separate chunks because the sum rule says we can. So the integral of x squared dx would be 1/3 x cubed, okay? The integral of 3x would be 3/2 x squared, and the integral of -2 would be -2x, okay? So that would be an equation. The answer to that problem would be an equation. There's always going to be a plus c at the end, okay? So 1/3 x cubed plus 3/2 x squared minus 2x plus c would be the answer to that indefinite integral. And if they gave us an initial condition, we would then solve for that c value. Okay, we would solve for that c value. Now, specific would be here, called the definite integral. The definite integral gives you a starting point and an ending point. Okay, a starting point and an ending point. So my starting point would be 0, my ending point would be 3. Now, what the indefinite integral tells me, the definite integral tells me, is the area under the curve from that point to that point. So I'm going to come in here and just draw this, right? So here's x equals 3, here's 0, and here's, f of x, whatever our original equation was, right? So there's f of x, okay? What this tells me is if I cut this off here and I cut this off here, it tells me this area under this curve, okay? And that can represent a bunch of things. If this is velocity, then this is the distance traveled. If this is marginal cost, then this is the total cost from 0 to 3 units. Okay, so it's a cost of 0 units plus the cost of 1 unit plus the cost of 2 units plus the cost of 3 units. Okay, it's very, very useful in a lot of science and business applications as well as engineering. Okay, so it gives you a total value. Okay, and this answer will always be a number. This answer will always be a number. Okay, so keep that in mind. Now, I want you to recall the integral of f of x dx is f of x plus c. Okay, so some function, if you take the integral, is a very similar function plus c. Now, here's a theorem for you. And it says the integral of f of x dx from a to b is equal to f of b minus f of a. Okay, so it's going to be that function value minus that function value. And I'm going to show you some examples of that in just a minute. All right, now, last thing here is the fundamental theorem of calculus. So I want to throw this one at you here. The fundamental theorem of calculus says if you take the limit as n approaches infinity for the summation of I equals 1 to n for a function times delta x. Now, we've seen this before. This is the notation for a Riemann sum. Okay? This is the notation for a Riemann sum. What this says is if the number of rectangles approaches infinity, okay, then it is equal to the definite integral of f of x. Okay, so basically what this is telling me is if I have an infinite number of rectangles in my Riemann sum, that equals the definite integral. So what this allows us to do is this gives us a mathematical proof that the area under the curve is in fact the definite integral. Okay? So let's take and do a couple of examples. Let's do a couple of examples. So I've got to get my paper here. Okay? So find the following definite integrals, give both the equation and the numerical value rounded to 3 decimal places. So what I'm really asking you for is to find the indefinite integral and then find the definite integral. Okay? So here's what we're going to do. We're going to start this equation by ignoring the 0 and the 5, and we're going to ask what is the integral of x squared? Well, the general power rule for integration says that we add 1 to the power. Okay? Now, if I take the derivative of this, I will get 3x squared. Well, I don't have a 3 here, so I have to get rid of that, and I get rid of that with a 1/3. Okay, so 1/3 x cubed. Now, that is the equation of the integral. That is the indefinite integral, and we, of course, could add plus c, but we don't do that because we don't have a way to evaluate c. Okay, so whenever you've got numbers here and here, we don't add a plus c. Okay, now we are going to add something though. Okay, so this line means take this equation and evaluate it from 0 to 5. So here goes 1/3 5 cubed minus 1/3 times 0 cubed. Now, lucky me, 1/3 times 0 cubed is 0. So all I have to do is evaluate this guy. Well, 5 cubed is 125. So this is 125 over 3. And will 3 go into 125? I do not believe it will. Let's see, 5, 6, nope, it will not. Okay, so 3 won't go into 125, and so this is our answer. Now, if they wanted a decimal or a mixed number, of course you could reduce this down to a mixed number, or you could turn this into a decimal. Okay, it's going to depend greatly on your teacher and your textbook. For me, I always want definite integrals as a decimal, and the reason I want that is because they're applications, and applications are typically decimals. Okay, but your textbook will want either a mixed number or an improper fraction. So if that's the case, that's how you want to leave your answer. Okay, cool. So take this one, number 2. What have we got here? The integral of e to the x from 1 to 3. Okay, so first thing we're going to do is just this part. We're going to do this part here. Okay, what is the integral of e to the x? Well, it's e to the x. How do I know that? Because the derivative of e to the x is e to the x. So always, always, always in your mind, you got to take what you write, do the derivative, and see if you get what you started with. Okay, and we're going to evaluate that from 1 to 3. Okay, so what's that look like? That's e to the 3 minus e to the 1. E to the 3 minus e to the 1. Well, e to the 3 minus e to the 1 is e squared. Okay, and so that would be my answer. Now, what if your textbook wanted a numerical value, a decimal? Well, you need a calculator for that. So let me grab my calculator. So here's the old handy dandy pocket brain, and we're going to type e squared, and we get this decimal 7.389, etc., 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 and our directions said to round to 3 decimal places, right? So we take and we round that to 3, so it'd be 389. There's a 0 there, so we round down. So this would be 7.389. Okay, so those would be my exact and approximate answers. Okay, take our third one here, right? The integral of 3 over x, there should be a dx there, from -6 to -1, right? So first we do the indefinite integral part. We ignore those two end pieces. We find the integral of 3 over x. Okay, well, I look at this as the integral of 1 over x times 3. Remember the constant multiplier rule, you can pull that multiplier out. Well, what's the integral of 1 over x? Well, it's natural log of x. How do I know that? Because natural log of x, the derivative is 1 over x. So the integral of 1 over x has to be natural log because they're opposites. They're inverse operations. And then, of course, that 3 has to get copied. So 3 ln x. So 3 ln x, and this is going to be evaluated from where? -6 to -1. And then you have to remember, oh crap, what does this rule actually say? It says that this integral is natural log of the absolute value of x unless x is positive. Well, because both of these are negative, guess what? We've got to include that absolute value. Okay? So if you forget that, sometimes it can mess you up. So, okay, now what? Well, we're going to have 3 natural log of 6 minus 3 natural log, natural log of 1. Okay? So 3 natural log of 6 minus 3 natural log of 1. Okay? And so that would be my exact answer. That would be my exact answer. Okay? Now my approximate answer, I'd have to take the handy-dandy pocket brain here and I'd have to type these in. So 3 times natural log of 6 minus 3 times natural log of 1. And I get 5.375 if I round that to 3 decimal places, because there's a 2 after that 5, so I round down. Okay? Cool. All right. Now, one more of these. Let's try one more. So the indefinite integral of x squared minus 4x plus 3, right? So what's the indefinite integral of this guy, right? So x squared is going to be x cubed. And if I take his derivative, I get 3x squared, which means I've got to take care of that with a 1/3. Minus, now, x will be x squared. What do I have to do to get this 4? Well, 2 times 2 will give me 4, right? And then the 3 will just be 3x, and then 1 times 3 gives me 3, and I don't have to do anything with that. And I leave the plus c off because I have a definite integral. If those weren't there, I'd put plus c, and that'd be my answer, okay? So I need to see this on every integration problem. Can you give me the indefinite integral, and then can you evaluate the definite integral, okay? And so we're going to evaluate this from -1 to 3, right? So what do? We take 1/3, 3 cubed, minus 2, 3 squared, plus 3 times 3, minus, I'm going to take all of that, minus 1/3 times -1 cubed, minus 2 times -1 squared, plus 3 times -1. Okay, all of that. Wow. And so we're going to start typing, right? So I know 3 cubed is 27, and 1/3 of 27 is 9. So that'll be 9. And then 3 squared is 9, and 2 times 9 is 18, right? And then 3 times 3 is 9. And so I get 9 minus 18 plus 9, which magically comes up as 0. Okay, cool. How about here? -1 cubed is -1. And so that's going to be -1/3. And -1 squared is 1. And 2 times 1 is 2. And then 3 times -1 would be -3. And so I get -3 and -2 make -5. So this is like -5 and 1/3. Okay? Or 16/3 if you want to write it as an improper fraction. Okay? Now what happens when you say 0 minus negative? And make sure you get that right. These 3 add up to a negative, but that negative's got to get copied. So a negative of a negative is a positive. So this answer would be 5 and 1/3 or 16/3, depending on the format that they want. And then, of course, if you gave the decimal, I think everybody knows how to find that decimal, 5.333, if we round to 3 places. So one of those options will be your answer. They're all equivalent. So that is an introduction to definite integrals. If you have questions, let me know.